If you're looking for a job in data science and machine learning and you don't know how to build a web app, then you better keep watching. After I learned this skill, my job application to interview ratio went from about 8% all the way up to over 20%. Even crazier, my interview to offer ratio went from about 15% all the way to over 40%. Why, you might ask? Well, the answer is actually quite simple. Employers don't make money off of code residing in Jupyter notebooks. You can have this awesome machine learning model chilling in a Jupyter notebook and it doesn't give them any value. They need it to be in an app because unless it is, it doesn't do anything. Luckily, with Python's Flask framework, it isn't hard. Let me show you what we're going to build together. We're going to build this interactive web app that your employer can see all for free that has a machine learning model deployed on the Flask app itself. It's going to take live inputs from the user and produce outputs. It's going to show interactively this awesome graph where if we hover over any data point, the light blues are the training points, and whatever values we are curious about from the text box, we get those input-output pairs as well. If you have a different machine learning project in mind, absolutely, it'll only be slight differences to work that model into the app. A lot better than a Jupyter notebook, eh? You're going to need to subscribe to the channel because unless you do, you're going to miss the next video, which is probably even more important than this one. How to build a Flask app is obviously very important, but it is the next step where we deploy it on Heroku for free so that anybody, including your employer that you're trying to impress, can see your code and actually run the app. So subscribe and ring the notification bell so you know exactly when that video comes out so we can show your employer your awesome app. Also, I know you're a busy person and you might not have time to watch the whole video right now. If not, that's perfectly okay. Again, subscribe and ring the bell so you're not going to miss the content and you can watch it when you can. With all that being said, I'm super excited. Let's get started. I'll see you in there. Hi everyone, this is just a quick edit to remind you about your playback speed options. Remember, if you go to the bottom right, you can open up a gear and change your playback speed settings to slower or faster than it is currently. If you're just watching me code, then there's a decent chance you'd want to bump the speed up to 1.25 times or faster. If you're following along recreating the code, then the original speed is probably right, but you can still try playing with it a bit. Happy coding! So the first thing we have to do is set up our Python virtual environment, which is basically an encapsulated set of libraries that we're going to use for our project. Specifically, we're going to need Flask because, well, we're making a web app with Flask. We're also going to need NumPy, Pandas, Plotly. I chose to use Plotly as a graphing system instead of Matplotlib for a couple of reasons. And Plotly is going to require something called Kaleido. So we need those libraries. If you know how to do or already have done what I just said, then feel free to skip to the next section. You don't need to watch this. If you are still watching, I'm going to go over it the way that I want to do it. There's a bunch of different ways. I'm going to assume that you have Python installed and you have pip installed as well as vn. Okay, I'm not going to install those things for you. I'll link some things in the description so you can check that out. I'm just going to start here by using vn to make our virtual environment. So on Windows here, I would click here and type cmd. By the way, I want to do this in some new folder where there's nothing else in it. It's just dedicated to our app section. So I'll enter cmd, that opens up a command prompt, and I'm going to write on Windows. It might be slightly different on your machine, but you'll write something very close to Python or py-m vn to activate that module, and then make the name of the environment here. So I'm going to call it .env. It's very common, starting with a dot to make it a hidden file. Okay, and it's all done. All I showed here is I wrote dir to show the file names, and we'll see that .env is there. If you got no errors and you can't see it, that's just because it's a hidden file, but don't worry, it is there. And on Linux, you can actually write ls-a to show all of those hidden files. Now we can go ahead and activate our virtual environment. And to do that on Linux and Windows, it's very, very similar. You would do something along the lines of .environment/scripts/activate. Okay, and on Linux instead, I think it's bin instead of scripts, but something very similar. Now I need to install the libraries that I said earlier into this environment, and I'm just going to do it from my file. So I actually have a file called requirements.txt that I can install everything from, and that's in my GitHub if you're following along. Okay, so off screen I just put my requirements file in this folder. See if I go dir, there's a requirements.txt file. So now what I can do, I'm still in my virtual environment, and if I didn't show you earlier, it's this thing here. It shows you that you're in your virtual environment, and I can do pip install -r requirements.txt. Now what that does is just adds everything from that requirements file into our virtual environment. So you can see all these libraries that it's trying to get. And at the end, hopefully everything went okay there. If you had trouble there, look up some error messages or maybe message me. I can try and help you out. Okay, so now we are ready to start coding. So using whatever coding editor you like, it doesn't really matter. We're not going to use many features from the IDE unless you want to, but I'm going to use VS Code. And so I'm going to go open that up right now, and our folder that we are using for our app, whichever one you chose. So I'm going to navigate to desktop, tutorial. Okay, and now we're really ready to get coding. So the first thing we're going to do is make a very, very simple Flask app. Basically, if you go to the Flask page, we're going to copy and paste their exact Flask app, which is just a couple lines. To do that, we're going to make a folder in our main folder here, and it's going to be called app. And then within app, we need to make a Python file called app.py. So if you were following along, you'd probably go to the Flask documentation, so I'll go ahead and do that. They have a quick start, and here is a 1, 2, 3, 4, 5, 6, or 7 line code for a simple Flask app. And we're not going to worry about all the details. I'll talk a little bit about how it's working. The main point is that as data scientists, you don't need to learn every single thing about Flask. Of course, you should understand a little bit about how it works. Flask is for people like us that want to deploy machine learning models in the real world, but don't need a huge thing like Django for making your website. The easiest way to explain how this is working is really just by using it. And so we use this by going into our command prompt and making sure that we can see the app folder. Okay, so we want to actually go into that app folder. So I'm going to cd into it. And now you should see your app.py file here. So here, if you write Flask run, and make sure you're still in your virtual environment or this isn't going to work. If I write Flask run, it's going to spin up a development server. So don't use this in production as it says. Or if I go here, then it's going to show our app. And all it says is hello world. And that makes sense because all our app is doing, as you see, is really returning hello world. So all this thing is doing is when we started up Flask run, that was doing this initial stuff and defining our functions. So it makes an app, it makes a Flask app, and then it defines this function with this decorator thing, which is saying upon going to the root, which if you see here, if I type slash here, it goes to the exact same thing. It just doesn't show it. Imagine if we were facebook.com. Then 127.0. whatever, that would be instead facebook.com, and there'd be a slash here. Upon going to this, it says, hey, if you're going here, call this function. That's all Flask is doing. And since we went there, it's calling this function and it's returning the string of hello world. Normally we would actually return some HTML, and technically we are kind of returning HTML because we're returning a string and it's going to kind of convert that into HTML. We can see what's going on if you ever go to right click here, click inspect, then you can see that it kind of turns this into an HTML page, and so we have a body with hello world and that's it. That's what it's doing behind the scenes, is converting this thing into a proper HTML page. Okay, now believe it or not, I'm actually not going to use Flask for a while now because we have a lot to do. Specifically, I'm going to make our machine learning model, and I'm going to do that on Google Colab because it's going to be a very interactive thing. And as you saw, we're going to make a graph at the end, and so we want to do this in an interactive way at first, and then later we'll translate it to our app. If you don't want to see me make the model, that's fine. You can skip to the next section where you basically see me saving this model as a .joblib file. If you are watching, let's go on to Google Colab and make a machine learning model. So it's as easy as Google Colab. I write that, click on it, I'll make a new notebook, and I will call that Save ML model. That's most of what it's doing here. We'll do a little bit different at the end. We are going to use scikit-learn to make a linear regression model. If I just zoom in a little bit here, hopefully that's better, and I can import. So from sklearn linear model, import linear regression. So let's make sure that works. That's fine. So import pandas as PD. We almost always want pandas when we're dealing with this kind of thing. We're also going to need NumPy. Import NumPy as NP. We're going to need Plotly eventually. I'll worry about importing that later. We're going to download our data, which if you've seen my other tutorials, you'll probably recognize this data set. It's what I use when I want machine learning to look simple. I'm going to wget this thing, which is just the ages and heights of some people. And actually some information in there is wrong, so we're going to have to clean it up a little bit, which is perfectly fine. So I can open this with data is equal to pandas.read. It's a pickle file. Let me just show you over here in case you haven't seen it. Ages and heights.pkl. So I can do data is equal to pd.read pickle, and then I pass the name of that file. And so if I output this, if I just write data, you'll see that I have this pandas data frame. I think I need to zoom out a little bit. That's a little better. Now I have the age and height of people, where this is their age in years, and this is their height in inches. And there is actually a bit of a problem in this data set. If we see we have age.hist, sorry, I need to define this thing first. So I'll set age is actually equal to the data sub the age, so that's that column, and then I'll get heights as well is equal to data sub the height. And then if I do ages.hist, watch what this produces. It actually has some values less than 0. And we can see this with ages sub ages less than 0. That outputs all of these different things. So what we actually want is data equal to data where the ages are greater than 0. So where ages is greater than 0. And if we have data again, then if we do data.hist, I'll make a histogram for both of them now and just show you that they're both fine. Here on age, it stops at the 0 point, and for height, it's also greater than 0. So now the data set is clean. Okay, now let's go ahead and make a scatter plot for our data. And we could do that with data.plot.scatter and pass in x is equal to the age column. Notice that we're actually passing the column name matching the data frame and not the variable that we made earlier called ages. So here I'm saying data.plot.scatter x is equal to age and y is equal to the height, and we get a scatter plot of our data, and clearly there's a linear relationship there. And our data, nothing's below 0 and nothing's too high. It looks pretty clean. We're now at the point where I want to use Plotly for graphing, and yes, Matplotlib would do the job just fine here. It doesn't look quite as good as I want to, but that would be fine. There is a bit of a problem when we go to using that in our app. Yes, you can solve it still, but Plotly code is just as easy to write as Matplotlib in my opinion, if not easier. You can make a lot better looking graphs, and I don't know why it's not taught before Matplotlib. So let's go ahead and install Plotly. There's not much to do installing for Plotly for now. Later we're going to need to install requirements so that we can save a file, but for now we can actually import the library. It's a Python library like any other. Collab actually has it installed already for us. So what I can do is import plotly.express as px, and I can also import something else. Import plotly.graph objects as geo. So we got those in there, and now we are ready. I'm just going to make the exact same plot we had here, but with Plotly so that we can copy and paste our graph later. Okay, and as you'll see, it looks a lot like Matplotlib, but it's not difficult at all. I can write fig is equal to px.scatter, x equals ages, y equals heights. So we're just passing our x and our y, it makes sense. Here we're not passing the names of the columns because we're not talking about the data frame. We're talking about the actual series objects, or the variables I tied to the columns themselves. So x is equal to ages, y is equal to heights, and we can set a title is equal to height versus age of people. It's about 100 people, a little less. And then I can do labels, so passing labels so that it looks good. Labels is equal to this dictionary object where I have x, and that will say what is the x label, age in years. And now we'll also make one for y, and that's going to be the height in inches, and that should work just fine. The only thing we have to do is fig.show. Alright, and there's a big Plotly graph. It's a little too big for the screen, so let me zoom out a bit. Here we go. So we have the title up here, height versus age of people, height in inches, age in years, and it even does this thing where if I zoom in, maybe you'll see it better. It shows you, if you click on a point or even just hover over it, it shows you the x and the y of that. If you're not subscribed to the channel and you're watching this, I'm not sure why you're not subscribed to the channel. Also, whether you're subscribed or not, if you enjoy what you've seen so far, please like the video, it would help a lot. We have this awesome interactive graph for now in Collab where we can look at all these points, and after this we're going to put a line. We're going to do a linear regression where this height is based off of the age, and so we draw a line through that using scikit-learn's linear regression model. And now we're going to add that linear regression to this graph. Okay, and I'm sure that some of you noticed that we actually still have negative ages here, and that's because I forgot to update our variables after we fixed it. So I said data is equal to the updated ages, only the positive ones, except now we want the ages is equal to data sub age, and heights is equal to data sub height. And now that they're updated, what we can do is run this again, and we'll see that those are now removed. Okay, so as I said, to make our model, we're going to need scikit-learn. First, we actually need to convert our variables to numpy arrays because scikit prefers that. So I'll set ages numpy is equal to ages.toNumpy. So it's just converting the series to a numpy array. We'll do that exact same thing for the heights. And I'll just show you what one of them are. So you can see it's a numpy array. And let's just look at the shape of this thing. Okay, so we can see it has 93 values, and it's just a vector of 93. Heights also has the exact same shape, and actually we're happy with how heights looks, but we're not happy with how ages looks, and that's because of the nature of the problem that we're doing. We're going to make a simple linear regression, which means a linear regression with specifically one feature. Scikit-learn's linear regression model, if you remember, I'll go up here. We imported something called linear regression. I don't think they have something called simple linear regression. Their linear regression wants to take in two things, an x and a y, where that x is actually a matrix. So it's going to be basically a list of data points, and each of those data points is going to be, for us it's going to be 1, but we can't just make it a list of numbers. We're going to make it a list of numbers where that inner list is just 1. And if that was confusing, then it's not too complicated. I just mean that we're going to reshape ages like this. So we're going to say ages numpy reshaped, set that equal to ages numpy, but dot reshape. The shape that we want to pass it is in the length of ages. Okay, so we want a list of data points. So that's how many data points we have. And then this is going to be how many features we have, and we only have 1. So that ages numpy reshaped now looks like this instead. So now that we have ages reshaped, and we also have just our heights as a shape we're already happy with, we can actually go ahead with making our scikit-learn linear model. And if you remember, we imported something called linear regression. So how I would use this is I'll say model is equal to linear regression. So we're calling this thing, and then bracket dot fit, and this is where we pass in that x and y we just talked about. So our x is going to be ages.numpy reshaped, so there's that, and then the y is going to be the heights, okay, heights numpy still, and that is actually fine. It's going to run the model and fit it, so it's going to find the right parameters. It's simple linear regression, so there's going to be an intercept and one slope term, or a beta naught is an intercept and a beta 1 is a coefficient. We can look at both, but I'm only going to look at the coefficient for now, the beta 1, or the slope value, and so I can do that with model.coef underscore, and that's going to output the proper slope there. Okay, so what this is really saying is that for a 1 unit increase in the input, so for a 1 year increase in age of a person, we're expecting that on average, the height of that person is going to go up by 2 inches, at least in this valid range of people from about 0 years old to around 18 years old. That seems to be true. Okay, and there's methods numerically to check how well the model actually fit the data, but let's just plot the data from before along with the model's output over that range. So we're going to put a line through that data and just eyeball it to see how well we think it's doing. Our valid range of input is from but the ages 0 to 18. So if I get the values 0 to 18 as integers, I'll just get a bunch of data points, and then we can plot those data points and put a line through them. I'll get x new is equal to, say, the list of the range up until 19. So range 19 is really 0, 1, 2, 3 up until 18. We make that into a Python list, and then what I'm going to do is actually get the numpy dot array of this thing, and same with before when we were fitting the model, it required the input to be in this matrix format, so we're going to do that same thing again. We want it to reshape, and here I'm just going to keep hard coding the 19s, reshape it into 19 by 1, and that's going to be our inputs, which we want outputs for. So we'll get preds for predictions is equal to model.predict, and that takes in this matrix, and so we'll just give it x new. That should return a numpy array of just a vector of outputs. And now what we can do is grab our previous graph. A lot of it's going to be the same, so I'm just going to copy all of this and put it down below. That's the exact same graph as before, and just to show you that this works fine, I'll run it. And now what we want to do is put the line through that data. And we already have the inputs and outputs for it. We just need to make the line using this. So with Plotly, we would do fig.addTrace. And this is where we're going to use that other import for Plotly. If you remember, it was go. So we're going to make a go scatter. Okay, so this scatter is actually a capital. It's kind of kind of weird here, but that's fine. Scatter, where we pass x is equal to that x new, and we want y equal to those predictions. So y is equal to preds, we called it. And then the big part is mode is equal to lines, so that we're not actually doing a scatter plot. I know it's kind of weird, it's saying scatter when we're connecting it with lines, but that's fine. So mode is equal to lines, and just for legend's sake, we're going to write name is equal to model. Okay, so you might think that would work, or you caught that actually this array thing, the x's, so basically we have this reshaped into a matrix. It's not really going to want a matrix as input, it's going to want just this one-dimensional thing. So unfortunately we actually have to reshape it again, and so this thing, x new, we must reshape it into just the 19. Okay, so now we can see our model through that. We have over here the legend, it says model, that's beautiful, and it's directly from the range 0 up until 18. Technically we didn't need so many points in the middle. What we actually did is plotted for 0 and then that one, 1 and then up, 2 and then up, so on up until 18 for all the integers in that range. We could have just did 0 and 18. Okay, so we've successfully made our machine learning model, we fit a scikit-learn linear regression model, and we used it to make predictions, and we fit it in this entire range. Okay, so welcome back to people that skipped this section because you didn't want to see the training part. Now what we're going to do is import this library from joblib. So from joblib, we're going to import dump and load. We're going to take a dump and we're going to load it. So basically, the point is that we have this machine learning model now, and we want to save it to a file and be able to load it from a file. So this is actually really, really easy. First, take a dump. So to make a dump, we're just going to write dump. For that, we need to pass a model that's in memory right now, as well as a file ending with .joblib. So we have to do dump, and we'll pass our model in, and then we're going to pass the name of it, and we'll just call it model.joblib because we're only going to have the one model. Okay, so what that does is just saves this model to a file so that it can be loaded. And you'll see here, it saves it right here. Model.joblib now exists, and we can load it from file like this, wherever this file is. That's the important part. So say model in, I'll say. So model loaded in is equal to load, and all that's going to take, you could probably guess, is the name of the file, and that file name is model.joblib. So that loads this file from disk into memory, and then if I have model in, say .predict, I'll give it the numpy.array. It's going to take the exact same thing it did before because it's the same model, and so it's going to take, say, the numpy.array of the list of 1. It's again that matrix. I know it looks kind of weird here with all the brackets, but this is one data point and one feature, so it's going to look like that. And this is our output, which again is a one-dimensional numpy array. So now what we're going to do is actually download that file that we made and put it into our Flask application. So I have model.joblib, and sorry, I closed this off screen, but I need to open up our code again in the base app folder. So under app, we want to put the file right there. So we download it onto our machine, and I'm going to drag it over like this. Under the app folder, it'll go right there, and now we can read it in the app program. In the app Python file, we're going to be able to load that same thing using those same libraries. That's why we put all those libraries in our virtual environment, because right now we're going to need some of them. So let's just test super quickly if we can do this. We know it's going to work, but just to make sure it works, we're going to import some of the same libraries that we did, and we're going to have, we don't need linear regression because we're not going to be fitting a model again. We need that joblib thing from before, as well as importing numpy. So let's get numpy because that's how it takes data, right? It still takes numpy arrays, and so we're probably going to need numpy to do that. And later we'll probably import all of the other ones as well, but for now we're going to import numpy as np so that we can give it data, and to get our model, actually we don't need dump, we're just going to need load because we're not going to save the file or save the model anymore, we're just going to load it. Okay, so to test this thing, we'll keep hello world as a title, this is fine, but instead of returning hello world, let's just make a numpy array. So we'll say test numpy input. Okay, so just some random input is going to be, say, the numpy array of 1, 2, and say 17 as inputs. and we should be able to load our model. So we'll say model is equal to load. So we imported that library or that function. So load, and then pass the name of that file. So model.joblib. Okay, since our file's on our local device here, we can load it just like we did in Collab. So model is equal to load of that. It should load it into our Flask program now. And now what we can do is same as before, preds, and actually it's going to be easiest just to copy and paste that from earlier. We have preds is equal to model.predict, not x new, but we can change that to the variable we did use here. That's test numpy input. Okay, so it's just getting predictions. It should be a numpy array of just length 3. And we're just going to return this as a string. So what we want is really preds as string is equal to convert this to a string. So preds as a string. Let's just return the predictions that were made. Okay, so let's return preds as string. We'll save that. And then from here, I could do Flask run. We see our outputs. So the first thing we need to do is make that function whose job is to take some inputs, so a list of, say, integers or a list of floats, and it's going to produce the model outputs. So it also has to take in the model as a parameter, or possibly the model file. I'm going to pass in the model itself, and it's going to output a file which is basically that graph. So it's going to output a picture. Specifically, we're going to do an SVG of that graph. Okay, so as is the case for any interactive type thing, I want to use Google Colab. So I'm going to go in there, and we have to make a function that basically makes this graph, but with these purple dots where we asked for inputs. So we're going to build this thing step by step. It's actually going to be a pretty big function, but for now, we're going to write something called make picture. So we're going to make a function define make picture, and it's going to take in a bunch of things, but for now, building it up, we're going to have training data file name. And okay, it's training data, but remember, we're assuming our model is already trained. And eventually, actually, I'll write it now. We'll say model is going to be an actual model in main memory. So the first thing we're going to do is get data, and that's that data frame from before. Data is equal to pandas.read pickle the training data file name. Okay, and that thing better end in .pkl, otherwise that's not going to work. So that's just going to load in that raw data frame. So ages and heights.pkl, it's going to be that same one. We'll download that and put that on the Flask app, and then it's going to read that data frame into main memory so that we can go on making our graph. And to make the other parts of the graph, we should be able to copy and paste most of what we had before. So this is going to just be grabbing random stuff from before, sorry about that. But we need a couple things. We need to set the ages and the heights from the data frame, and we do that not right there, we do that here. So we grab ages and heights, and actually we need to do this as well. We need to get only the proper data where the age is greater than 0. So we'll grab that, and we'll put that in our function. Okay, so now we've loaded the data. We have tied variables ages and heights to that. Now we can copy our code from our scatter plot with the line, because as you'll see here, we have x new. We make that on the fly with NumPy. That should be fine. We have predictions is model.predict with that. It should be able to do that because we're passing in model as a parameter into our function. We're going to make fig is a scatter of just the ages, which we have in there already, and the heights. So that's fine. Making our labels, we add a trace of a scatter plot, and then we reshape x new. We get our predictions, which we're going to make right here, and this should actually be fine. Okay, so we should be able to copy all of this code right here, and with the variables we got earlier, that should work. So let's actually just test this thing right now and see what it does. We need to be able to pass in our model, and so I can pass in both the data, so that's ages and heights.pkl, so that, as well as the model, which I have something earlier called model in. Okay, and I can actually see that we're referencing ages before we're defining it here, so we actually need to make it up here and then use it and then set it again like we did before. So then if we run this function, it will produce our same graph as before, except now it's good because it's all modularized into this function so that we can run it on Flask a lot easier. Okay, so now we need to add a new parameter because the point is that we're passing in inputs to this, and so we're going to assume when it gets to this function, that's going to be in a NumPy array. Of course, the user is just going to pass a bunch of numbers into a text box, but we're going to do some processing in the middle there to convert it into the array that we want. And so here we're assuming that it's already in the array that we want. So we're going to say new input, new INP NumPy array. So these are our new inputs. We need to get new outputs, so those purple blobs that are going to be on the line somewhere. We need to first make those outputs from that input, and so we'll say new preds, or new predictions, is going to be equal to the model.predict, and we pass just that properly formatted thing, and that should be our outputs, and then we need to be able to add these points, and so to do that, we're going to make a customized, kind of pretty graphing function here. So we need to add a trace to the figure. So we do fig.add trace, and it's going to be a go.scatter. Okay, go.scatter. We're going to set x equal to the new input NumPy array, except remember that's not formatted in the way that it wants it. It actually needs to be reshaped into just the length of what it is, and that's fine. Okay, so the just the vector. So after we reshaped that, it's getting a little bit confusing here with all the brackets. I'm getting a little bit lost, but here it is. So y is going to be equal to the new predictions. Okay, so that's fine. That's properly formatted as well. Here I'm going to pass the legend name, or what the legend would call it. So its name is going to be new outputs. Okay, we actually need to remind it that this is points and not a line. I played around with it earlier, and it thinks that it's a line at this point, so we need to change it to be mode is equal to markers, saying it's actual points. And here I'm just going to pass this dictionary of a bunch of presets that I found earlier would make it look good. We're going to set marker equal to the dict, so the dictionary of color is equal to purple. Okay, feel free to play around with that if you don't want that. That's totally fine. Color is equal to purple. Size is equal to 20. I recommend keeping something close to that so it doesn't look too weird. And then line is going to be equal to a dictionary as well. Line is going to be the dict of color is equal to purple. I don't know if this is totally necessary, but again, play around with it however you want to make the graph. That's really up to you. Width is equal to 2. I found that looked pretty good. And there's a bunch of brackets here. Oh man, is it confusing? But I think that's pointing to the last one. Yes, that looks right. Okay, and this should work just fine. If I try this again with some test input, maybe the numpy.array of 1 and 17. Okay, so if I make picture with that, it's going to say function takes at most one keyword for we're given. Okay, so I think I have an error with brackets here. And yes, there should actually be a bracket here. There it is. Okay, so we inputted the 1 and 17 as inputs for age, and it ran the model, and it outputted them onto the graph, just like that. Alright, so that's very nice. One other thing we finally want to do with this function is to make it print the graph to a file. Okay, so right now we're just doing fig.show, and we don't really want to do that, at least not in our Flask application. We don't, maybe we do here. But what we want to do, actually we can keep it here for now, but the main point, or the main part is to write fig.writeImage. Okay, so we write image, and we pass the name of the file that we want to call it. So let's call it just output file, where that is going to be a parameter to our function. Okay, so if we set output file here, and it's going to be an SVG. Okay, so it's really important that we call this thing with something ending in .svg so that it's a high resolution graphic. Alright, so what we can do here, and actually let me change one thing here, we can actually write the width equal to 800. Okay, so I just tested earlier and that's going to be a good number for our application. So width equals 800, and it's going to write that file to this name that we're going to pass in as a parameter. We're actually going to have a problem here, and it's kind of irritating. Make picture requires one. Well, that's a problem, but that's a problem we can fix very easily. I can say x.svg or whatever we want to call it. We're going to have another problem, which is collab saying we need something called orca, and you can just copy my notebook. I'm going to copy and paste some things into the top with our imports to install orca. What's even more annoying is we're going to do it differently when we go to Flask, but when we go to Flask, it's actually going to be a lot easier, so don't worry about that at all. Okay, so off screen I copied what we needed, and I'm just going to run that in that cell, and it's going to run for a little while, done with this orca thing, and install it. And although it doesn't look like it here, it actually is done. Okay, so now that was actually all we needed to do. We had installed orca. Instead, we're going to use Kaleido and Flask. If you remember, we installed that library. It's just a lot easier on Collab if we do it this way. So if I call this again, and sorry, it took a little bit of time, but if we refresh over here, it did make x.svg, which we can look at. It kind of opens it as a web page, and we can open up x.svg, and we can see it's our nice pretty graph. Okay, we're very close to done with Collab for good, at least in this lesson. One more function I'm going to write is going to be, basically imagine that we're taking in a string of our inputs, which is going to be a comma-separated list of values, and we want to convert that into that NumPy array. Okay, so really it's going to do the processing between the input string and converting it to this thing right here. Obviously, we're not just passing it some actual NumPy array, we're going to pass it a variable which is processed from the user. Okay, so this really was called new input NumPy array because it's getting it from the user, but indirectly. We need to process it first, and so we're going to define a function called float string. So it takes in a bunch of floats, comma separated as a string, and it's going to convert that to NumPy array. Okay, and it's properly formatted so that our model can consume that easily. Okay, and so it's going to take as input a string, which is that comma separated list of values, and we want to do a couple things to process it. So first, we want to say floats. So we want to get a list of floats, a iterable, and so floats is equal to the float, so we want to convert it to a float. So I'm using Python list comprehension syntax. If you're not familiar with it, I'll explain it. We're going to take the float of x for x in the floats string dot split on comma. The easiest way to explain what we just did is really just to show it step by step. If we have the string of say 1 comma and then add some white space to show you that this is fine, 3.2, add some around there, comma, and then I'll put some white space at the end, which is going to be not okay actually currently. And so if we do dot split on comma, then that produces the list where it's going to be the string of 1 and then the string of 3.2 and then the string after the last comma, which is actually just a bunch of white space. And now what we're trying to do is convert each of these to a float because currently they are strings. And so if we get the float of x for x in this list, so each time x is going to be a string, we're trying to convert it to a floating point value, this is actually not going to work. Okay, so if I copy that same thing here, and I put it there, and I run that, it says could not convert to float because that last value is just the string of white space. Okay, it's actually fine that the 1 is, well obviously that's fine, just 1, converting that to a float, that'll work. It's actually fine doing float of space to space 3.2 space to space, that would actually be fine converting it to 3.2. The problem is just at the end there with that white space. So probably the easiest thing to do is just to define this really straightforward function, which is going to be define is float. So basically it takes a string, which we'll call s, and it returns true if it's a float and false if it isn't. Okay, and we're going to do this with a try catch. If you haven't seen that before, you'll see it here. Actually, it's try except in Python. I'm used to saying try catch from many other languages. We're going to try to do the float of s. Okay, and we don't even need to store that in a variable because we don't care about returning it. We're just checking if it is a float. So if it is, then this will pass and we can go to the next line here, or it will go to the next line here, and therefore we can return true that it is a float. Except if this ran into an error here, you see down here we ran into a value error, so what we'd actually get is a value error, and so we can write except. So if it throws an error, then it would go down here, and therefore we can immediately return false, because it can't be a float if it didn't properly convert it to a float. Now just to check if this function worked, let's try is, and I don't think I ran it here. That'll probably fail again, but that's fine, it still made the function. So we're going to try is float with this space thing, so 1 with a bunch of spaces. Yep, that's fine, regardless of if we have spaces. So if we don't have them, then that's still fine. If we make it a float, then that is still fine. If we have a float with some spaces around it, that is actually still fine. Now what we care about is finding this thing. So if this is a float, no, it's not. Okay, so what we can do here, you can actually add an if into this list comprehension syntax, and so we only want the float of x for this. If, you'd write it here, you'd say if x is a float, so we'd say is float of x. Okay, we only want those values. So there we get 1.0 and 3.2 from that, and that's exactly what we want. Okay, so let's not worry too much about our example here. We can clear some of our code because this is just trying to check what works. But here, this is exactly what we want. Is here we want float of x for x in the float string dot split if is float of x, and we would need to copy our function above that. And in fact, let's just keep it in that scope because we're never really going to use it outside of that. And fixing the indentation, that should work just fine. Clearing this up, we run this function, and just to test this thing, so floats string to numpy array of, and of course it's not actually doing what it's saying it's doing yet, we're not quite there yet, but if we pass it this string, say 1 and then some space 3 and then some space 3.2 comma and then some space afterwards, if we do that, it's, well, not going to return anything. Sorry, I forgot to say return floats, and what that does is returns all of those floats without any errors, so that's great. The only other thing we need to do is just to reshape this thing in the format that our prediction wants, and so we do floats dot reshape, and the first dimension should be the length of what it is. So how many do we have? We have the length of floats, and then we need 1, and it's actually not a numpy array already, so we need to make it the numpy array of this thing, and then we can reshape it. So if we do that, then it's our proper format, and we can use it just like that. Okay, so now we're able to take input from the user, at least once we get our UI, we can take our input from the user, process the text, the string with that function, this function float string to numpy array, we can process that, and we can pass that to our important function here. Okay, so here we can test it right here, and so we can call floats string to numpy array of, let's just pass this whole thing here. So if we pass this thing, then our function says, okay, I need to process this text, and then I'll produce the outputs, and here you go. Okay, don't close Collab because we're still going to need to copy the code from it, but we are officially done writing code in Collab. Before we turn our attention to Flask again, let me just download a couple things that we're going to need. We're going to be putting this data file onto our Flask app, so I'm going to go ahead and download that. And also, very similarly to how we did this thing over here, where we saved this picture, we actually want just a saved picture that looks very similar without the dots. And so I'm going to copy, I guess I lied, I said we were done coding in it, and here I am coding in it, but really 2 seconds here. I'm just going to run this cell above, because we're going to want this picture for our base UI. Just when you go to the screen, that's what you want to see first. So I'm going to do that. Sorry, that's the wrong spot. Right here, if I do that, output file is not defined, we'll call it, say, base pic.svg. It's going to run, save that, and put it here, and I'll download that as well. So now I have both basepic.svg as well as the data, and I can put that onto Flask. So let's go over to Flask, and for now I'm just going to put it in the app folder. We're going to move it very shortly actually. So if I go to downloads, I can put this here. So in app, in the app folder, I know it looks disgusting, but you don't actually have to look at the file. Basepic.svg as well as ages and heights.pkl. Put those both in the app folder, and they're there. Okay, so we have basepic.svg, and so with that, we can put that as our home screen picture. So when we go to our slash directory, I want to return that picture along with the text underneath it that says input some numbers, as well as a text field that is going to get those numbers. Don't worry about the actual processing of the text for now. I just want to be able to receive some text from the user and know that we got the text. So I'm just going to get rid of this code. We're going to write something fairly similar when we go to actually write our program, but that's okay. It's just a couple lines. I wouldn't worry about it. What I want to do is render a template, and I'll explain what that is later, except basically it's an HTML page with some special functionality to change that HTML page dynamically. And so what I want to do instead of returning a string is return the render template, and it's going to take a couple things, but for now I'm just going to pass it the name of our HTML page, which yes, we don't have one yet, but I'm going to call it index.html, and for that to exist, its render template is going to be in a templates folder. Okay, so we want in our app folder, we want something called templates. And then we can put in our index.html here. So let's go ahead and actually build an HTML file. So we'll call it index.html, put that under templates because it's a template. If this part is making you nervous, seriously don't worry about it. If you don't know HTML at all, I'll show you it. It's very easy. If you know HTML but you don't know what a template is, it's also a very easy transition. Don't worry about it at all. Okay, so first thing I'm just going to center this stuff that's below here. So I'm going to write a center tag. And if you haven't seen HTML, it goes like this. You write these tags with angle brackets, you open them, and then you close them later. Sometimes you close them in the same time that you open them, but sometimes you don't. Okay, so here with center, I can do it like that. And then here, I'm just going to add our image. And so I'm going to add an image tag, and I'm going to set an attribute. So here I have an image, I'll set the source, which is basically the link or where it's located. I'm actually going to change where it's located. As I said before, I want to push it somewhere else. And so basepic.svg, I actually want in the app folder, I'm going to make a folder called static, and I'm going to put basepic.svg within that folder. Okay, yes, I'm sure I want to move it. And here, okay, so now it's in static/basepic.svg. So I should be able to say static/basepic.svg. And I know it might be weird that I'm starting with static when you're saying like, isn't it like an absolute path or something? Like, how do I know here? So actually here, it's going to assume that our root directory is actually the app folder. And so if I'm already at the app folder, then I can say static/basepic.svg. That should be the location of this thing. And then I'm just going to add a height attribute equal to, say, 600. And I'm going to close that with slash bracket like this. So you see here I'm closing it with this other tag, but here for an image I'm going to basically self-close it here. And then I'm going to save this file. Actually, I'm going to indent this a little bit just to show that, you know, it's nested under here under the center. And let's go and just boot up Flask. So I have set up that I'm in the right spot. So I show that I have my app.py here. I have my virtual environment, and I should be able to do Flask run. There it is. It loaded up basepic.svg right in the middle. You can tell it's centered. So now we're ready to add a form to our HTML page. So down below here, we want a label that says input some numbers, and we want some text field that we can enter as a user right here, and we can process that text within the program. To do that, I said we would use what's called a form. So I'm going to make a form, and I'm going to set a method attribute equal to post, which basically means, you know, the user is going to give us some information. So if they send us information, we can do some processing on the app side, and then we can return something different based off of what the user gave us. So we actually need three things. We're going to need a label, and then a text box for our text, and then we're going to need a submit button to actually enter that text and call the post method right here. Let's first add the label, and that really is just label, and then we put text in it saying input a comma separated list of age values colon space. And then we're going to have a text box, and for that, that's going to be an input. That's going to have a name. So this is basically how we reference this thing. Its name is equal to whatever we want. It's just going to be text. and by default this is going to be a text box, so this is actually fine as is. Now we need our button, and it's going to be also an input, except by default this is a text box, so we need to set type equal to button. And actually there's one special called submit for submit button. And so what that's going to do is when you click that button, it's going to say, oh, we're doing a post method. I have text here. I'm going to submit that to the app. And I'll show you in a moment where we can actually reference that thing. But for now, if we run Flask, and I already did it off screen, I set it up, and you'll see if you refresh your page, you're going to see this label down here with this text box and submit. So now, of course, we don't have the processing for this, but say that we had, tree here. We sent in some text. Later it's going to be numbers, but for now let's try this. Notice method not allowed. This method is not allowed for the requested URL. And this makes sense because if we go into here, it should call this function, except it's only allowed get methods by default. We're trying a post method when we click submit. When we click this button here, it's trying to do a post. You can see here for method equals post. It's going to do a post method, but that's not allowed on this URL. On slash, by default, the only methods available are get. So we have to do methods is equal to the list of the allowed ones. We can allow get methods. We can also allow post methods. And now if we rerun our app, okay, so we have this, let's try it again, say 12, we submit. Now it doesn't do anything different, but at least it didn't crash because we called this function, we still returned render template. It was allowed because we did a post method and it didn't do anything, but we still returned the exact same thing. What we're going to do now is do something different based on if it is a GET request, which by the way is just if I go here to a site, this is going to do a GET request, but here it's going to do a post method or post request because that's what we told it to do. So now what I want to do is if we're doing a GET method on just the root directory, then I want to just load the page, and we're already doing that. But if I choose to do a post method on this, which means I'm clicking the submit button, then that probably means I have some text here. What that means I want to do is I'll just return that text for now. Of course, we'd want to return the updated graph later, but for now, let's just make it, if it's a get method, we're going to return the page, and if it's a post method, we're assuming we have text here, we're going to grab that text, and let's just return it. To do both of these things, we actually need something in Flask called request. Okay, so for dealing with requests of all kinds. So here, we know that it's allowed to have a get and a post, but we don't know which one it is. So let's make an if statement where if request type, so basically request type, so as a string, that is equal to request, so we're calling that dot method. Okay, so that's an attribute. It's just going to return the string of either get or post. So request type string is equal to that, and so if request type string is equal to get, then let's return that information, just that page. Okay, so we want to return our base page. Again, that's saying if I went here and I typed slash, okay, I want to return that base page. There we go. But that's not the only possibility. Otherwise, that means it must be post because that's the only other one that's allowed. And so if it's a post, that means we should have information in our form. So we want to be able to access this name thing here. Okay, so this is our text box, and I had a name on purpose. If I call it text, that means I can refer to it with text is equal to request dot form and then sub text. Okay, so that's a dictionary where we can return the information based off of the names of things. So a tad boring for now, but let's just return that text processed so we know that we actually did something to it, and we can do whatever we want, not just to that string, but whatever we want with that string in terms of processing. So I'll return text dot upper just to show you we're doing something with the text. And here, if I save that and I rerun our Flask app, it might look the same, but I promise you it's not, because if we wrote tree here, then it's going to return that thing. And yes, it's not a great page, we're stuck here, but if I go back, it's going to return our page. But if I do a post method, it says, oh, okay, you want me to return the string here capitalized. Okay, I apologize for the quick jump there, but as you see, I'm back to this page. That's not important. What is important is I downloaded the smile.png, which is just a picture of a smile that we'll see shortly, and the point is to demonstrate what a template is in HTML. It actually allows for a lot of functionality like looping and if statements, except we don't need to worry about all of that. All we're going to use the template for is to decide what picture to show to the user. So right now we're showing this basepic.png or .svg. I instead might want to show smile.png because later I'm going to show a different graph based off of what I produce by our input that we use. Okay, so the plan is that we input some numbers here like 1, 2, 3, and then we do some processing. We make a new graph, we save that picture, and then we need to tell the template or the HTML to say, hey, I want this new picture. Right now we have index.html and it's extremely static. Like I really mean that, it's returning basepic.svg. And unless we actually named our thing basepic.svg every time, which by the way would overwrite our original picture, which isn't a great idea, what I want to do is say, hey, we've made this new graph and we've saved this picture locally. I want you to know that this is the picture that you want to send them. So to demonstrate this, let me put smile.png in our static folder as well. So now we have two different pictures in here. We have smile and we have SVG. SVG looks gross, but PNG looks fine in code. So what I need is really for this index.html source thing to be a variable. Okay, and to do that, we would use this cool syntax, and I'm going to copy or cut this because I'll probably use this later. We use this bracket syntax where we have double curly bracket and a double curly bracket, and then whatever we put in here is kind of Python code, not exactly. It's called Jinja syntax actually, but I'll show you some things that we can do with it. Specifically, I can write just a variable name. Okay, so if I wrote, say, href, right? So if I had this variable name, of course, this doesn't exist right now, but if we pass this thing over here, we can say href is equal to whatever we want it to be equal to. So I can set it to either smile.png or basepic.svg. I can do that either manually right now. I could literally write static / smile.png. Okay, and let me just show you that this works if I rerun our Flask app. So it returned this one instead. In our HTML, it passed it this thing. So it says, okay, I want href. I'm telling it over here that href is static / smile.png, so it knows that exists. I could as well change it to basepic.svg, but the point is that here, any code above here, I can try and figure out what I actually want this one to be. And actually, for the get method, that is when we just want to return not this smile picture, which is kind of funny to look at. We want to return static / basepic.svg. Okay, if we're doing a get, that just means that we are going to this index.html page. We want to see that base graph. We're not submitting any information, so actually we're fine with this for now, and we don't need to do anything up here. But if it's a post method, then we need to process the text that we get, make the graph, save the graph, and then basically call the same render template, but with a variable-based href. So I'd actually set href to be some variable here down below, and that would be the file name for whatever graph we saved. So just as a kind of intermediate step here, what I'll do is if we do a get request, then we really do want to return this one. Otherwise, we want to process our information, and then instead I'm going to return, sorry, that's a double return. I want to return the render template of index.html with href equal to a variable. Okay, so this is going to be path is equal to whatever it is. For now, I'm just going to set it to be the smile, but soon this will be the graph that we want it to be, or the file name of the graph we want it to be. So here we have static / smile.png, and so here I'm going to set href to be path. And now again, if we rerun our Flask app, we see that if we go to the base page and then we submit anything, it's not really processing the text anymore. We set whatever we want in here, we do a post method, and it's going to return some different picture. And here is where it would return the other graph that we want. Alright, so we're really in the home stretch here. All we have to do is get that stuff from Google Colab, play a little bit with it to make it work with our app, and then it's going to work just fine. So specifically, we made this huge make picture function, which if you remember, we basically give it a file name for reading in this pickle file. We give it the model loaded in already, the new input NumPy array properly formatted to make predictions upon, and then the output file, the name that we want to save our graph with. Here, if I copy this, and I can just put it down here, we're not going to have the best modularization and formatted Flask app. It's very small, and if you really want to learn all of that stuff, including Flask, then I recommend you learning somebody else's Flask tutorial. This is just to get up and running with machine learning, and so I'm going to make it not terrible, but maybe a little bit not formatted great. So here, I'm just going to copy and paste make picture, and I'm also going to copy and paste our floats string to NumPy array. Okay, so I have these two functions down here which I can now use. This one's job is to process the text and turn it into a NumPy array that's properly formatted, and this one we will need to give it the file name, which is just going to be the ages and heights. We're going to give it the model loaded in, so we have to load our model, and we have to, this is where we're going to pass it the processed text, and this is where we're going to pass it the whatever file name we want, which right now we're going to just call it predictionpick.svg. So that was a lot. I'll take it step by step here, and don't worry, it's not bad. So text is equal to request.form.txt. That's fine. Path for now, let's just set equal to this empty string. Now we need to properly make the graph here and set path to be the name of what we produced. So to do that, we need to obviously call make picture somehow. So we want to call make picture with some file name. So training data file name, that is going to be ages and heights.pkl. Okay, so that's already in here. That should work just fine. We have to pass it the model, so clearly we have to load in the model. I deleted that code from earlier, but we can copy it from Google Colab. It's very, very simple. All that we're doing is we dumped it here, and we can load it in with model in as load model.joblib, and we can predict right away. So here we can just load it in, read it from file, which again, remember, this is on this machine, so it can read from that file, and we load in the model. I'll just call it model. So then we can make picture with that and model, so that those parts are fine. Now new input NumPy array, this is the input NumPy array, which is basically the processed text. So we need to process the text first, which is what we use this function for, remember? So it takes this string of floats, and it's going to properly convert that to the NumPy array, and we can do that above here. We can call it with the string of text is actually what we called it. Okay, so text is request.form text. Remember, that's what actually we get from this text box. Okay, that's what we got. We called text equals request.form text. We got the information, and now if we process that text, then we can store that in a variable, and I'll say NumPy array is equal to float string to NumPy array of text, and so then we can actually pass that as well to our make picture function. So I can pass NumPy array to that thing, and then whatever output file name we want to call it, which for now, and we're going to change this shortly, I'm just going to call it predictionspick.svg. Okay, so hopefully that made sense. I know it was a lot, but maybe you can watch it again if that was a little fast. So at this part of the code, we've made the graph, but we haven't set path to be what we want. And so path is actually going to be, we'll just call that again for now, predictionspick.svg. And then I can also change it down here just to make it a little more clean. I would send this to be path. And here, href is equal to path. So now it's passing this predictionspick.svg, which is also going to be produced right here by this function because we're passing it path. And then it has the proper path, so it can give the source over here. It says, okay, you want this new graph we produced. Let me show you that one. So that's the idea. There's a little bit more to do here just in terms of specifics. We actually haven't imported most of our libraries, and so it's going to throw a bunch of errors. Let's try and catch them all at once. We know that we need to import pandas as PD. In fact, it's actually going to be a lot easier if we just go to Colab and we do import the things that we don't have. We don't need linear regression. We do need pandas. We got that. And we're going to need our graphing stuff as well. So let me just import those as well. Okay, so now that should work fine. We already installed this stuff in our virtual environment, so it's not going to complain about not having it. There is one thing that I kind of mentioned earlier, which is we have to make a slight change to our make picture function, which is where it's writing the image. So here, it's just because if we installed Kaleido, whose job is to faster way, or the more modern way, to do a plotly save graph. But in Collab, I couldn't get that to work. We did the Orca way. So here, the fix is very simple. I just add engine is equal to Kaleido. Make sure I spell that properly. Engine is equal to Kaleido. Finally, there's just one tiny little piece where I put the path up here to be predictions picked at SVG, and so that's showing you that the name is different, but actually we should be putting that in the static folder if we're going to serve that to Flask. So upon changing that, if we run our app again, we see that we have our graph. That's expected, but now if we do 1, 2, and then say 17.4, if I submit that, this is going to take a little bit because it's going to be producing a new graph. And actually, it's going to do something you didn't even expect, as well as do what we did expect. Check this out. Okay, so it took a little bit of time, probably just the first time, but it produces this graph where it's actually interactive. We get that whole Plotly interactive thing in this page, which it's spun up by itself. And if we don't want to look at that, if we want our actual app, we can just go here, and here it actually put, this is the part where we expected, which is just show our new picture, but also in a different tab, it opens up the interactive one. So that's awesome. And we're done, right? That's our app. We input things and then we get our output. Except, wait, actually, if you look over here, and you might have noticed it earlier, these aren't the same graph. And it's actually not because at runtime the graph wasn't produced. It's because that my browser is actually remembering the last name of this picture. So what I mean by that is it's caching. It cached predictionspick.svg, which if you were following along, you haven't even used that thing yet. But on my computer, I have. It's seen this exact path before, and it knows, oh, I know what predictionspick.svg is. It's this picture. Except it's not. We updated it, and I can show you right here. If we go to the new predictionspick.svg that we produced, okay, if I open this thing, this is the actual graph. So our browser is caching the image, and to make a temporary fix to that, let me just show you. If I press F12 when I go into the Chrome tab for our app, okay, so we're viewing it here. If I go to settings, and sorry, these settings, there's a setting for disable cache while DevTools is open. I have that on. So this thing I opened up is called DevTools, and so if cache is disabled while this thing is open, what I can do is then if I actually try this again, 1 to 17.4, okay, then I submit it. Yes, it's going to open this thing up again, but that's not the point. Is on our actual app, it's going to have the proper graph now because it's properly updating. It's not caching the old image. A clever way of solving this problem is just changing the name so that the name is different every time we make a graph. We would do this by making a random name and assigning that random name as the path. So specifically in our code, in here when we're making path, every time we're setting it to static /predictionspick.svg, the easiest thing to do is replace this predictionspick part with some random part. Okay, and I'll show you how to do that really easily. We import something called UUID. That's already in our virtual environment. It's just in the Python standard library. So we have that available. So what we can do is right above here, we can basically set random string. That's really what it is. It's just a random string. Set that equal to UUID.UUID4 bracket bracket dot hex. Okay, so if we get that, this itself is a random string, and so we can set path equal to static slash, and then instead of this part, we can end the string there, and then plus this random string, and then plus .svg, the string of that. Okay, so that's static slash plus some random part plus .svg. And now that we've done that, let's just show what it does by running our app. So if I go here, I have to reset the app. And it's reset. Let's just go there. Okay, so we have our graph. Let's give an input, 1, 2, 17.4 as before. So what does it show? It pops up again, the right interactive graph, so that's great. And also it outputs this correct graph. And if I just close this, do it again, say if I only wanted it 9.3. So if I submit that, then it gets it for 9.3. It does it for 9.3 again, just to prove it to you one more time. Say 1, 3, 6, 10, 15.4, 17.2. It can do all of those. It outputs them all there interactively. It has the old ones too, and it does all of them. It's updating because we can see if we go to our file system, it's actually making a new one each time. So that's our whole history. Okay, so that is our app. Okay, I hope that's pretty awesome, that it opens up this awesome interactive thing where we have deployed our machine learning model on the Flask app. So we made a machine learning model, we saved it, we put it on our Flask app, and we made an interactive user experience. Isn't that so much better than hiding it in a Jupyter notebook? I certainly think so. But if you want to show this to an employer, if you're trying to make a Flask app to show people, hey, I can actually make a web app, or even if you're not just trying to show to an employer, to show anyone that your app works and let them use the app, you need it to be hosted somewhere. And Heroku does this for free, and next video I'm going to walk you through how to deploy this on Heroku so that you can get your job. You can show off that you got this machine learning model, and it's not just buried in a notebook. People can go over and use it. And it's not that hard, but it's a little bit tricky. So if you're watching right now and you're not subscribed to the channel, please subscribe so we can go through that together. If you enjoyed the video, be sure to drop a like. I'd really appreciate it. It would help a lot. So thank you for that. You've worked really hard, and I'm proud of you for your work. So good job. I'll see you next time where we deploy our model on the cloud.